Last example, we're looking at irrational zeros. So we're going to treat that radical similarly to the way we treated that fraction. We're going to figure out where it came from. So it started as, or we are starting it as x equals the square root of 2. Well, how do I get that equal to 0? My first step is to square both sides. And then subtract the 2. So think about that the same way we treated the fraction. Instead of subtracting square root of 2 and ending up with a radical in our polynomial, we want integers. So think about other ways of solving. And then we set up our binomials using our asylum, so the rest of this process will be the same. We've got a complex root, so we've got x minus 2i, and we know it always comes with its conjugate, x plus 2i. And then we've got this root, the x squared minus 2 that we solved for our radical, and then putting our 2 in the asylum. And we'll call this function q of x. And multiply and solve. All right. So I'm going to multiply the first two binomials together, and I'm going to multiply the second two together. You always want to multiply your imaginary ones together to get those i's to cancel before you start multiplying with any other binomials. So because they're conjugates, I can skip multiplying those middle terms again. X times x gives me x squared. Negative 2i times positive 2i is negative 4i squared, which simplifies to a plus 4. Multiplying my last two down here, I've got x squared times x squared times negative 2, negative 2 times x, and negative 2 times negative 2. So now I'm going to distribute these together. And actually, I've done a lot of distribution. I haven't used the box method yet. I know some of you liked the box method. So we'll go ahead and set it up for this one. It's kind of a pain to distribute anyway. And this might be a little simpler. So we've got x cubed, negative 2x squared minus 2x plus 4. And then we multiply to get our answers in the box, and we'll combine our like terms. So remember, x squared times x cubed, when we're multiplying powers, we add the exponents. And then multiplying through by our 4. And combining our like terms. So our final function, I think I called it q of x. We've got x to the 5th. I don't see any like terms with that one. I don't see any like terms with my 2x to the 4th. And I've got a negative 2x cubed and a positive 4x cubed. I see 4x squared minus 8x squared minus 8x plus 16. So that is our function with roots of positive and negative 2i, square root of 2, and our last one was what, 2? And your U-try problems.